The fourth step in the GIS workflow is to examine, refine, and present the results. You've done all this hard work, and now it's time to communicate your findings to someone. There are three basic questions you need to ask yourself before presenting results. First, you need to define what your results are and how confident you are about them. Identify and disclose any known errors or discrepancies in the data you've used to reach your findings. Be sure to be upfront about those. Maybe your data is a bit older than you would like to have or is not as complete. Second, and perhaps the most important consideration for any project, is the intended audience. You should be thinking about your audience from the beginning, but it's here in the results and presentation phase where your audience is front and center. Will your results be shared with peers, clients who know little about GIS, or with the public through media? Third, we need to decide how to communicate those results to the intended audience. As I've said before, GIS results don't always get displayed on a map. Sometimes a simple table or written explanation will do the trick. GIS results can be shared through reports, maps, tables, charts, or on the web. If a map isn't the end goal, many times you'll create a map to communicate or highlight or supplement specific findings. Since a map is a typical result in geospatial applications, the design of the map is very important. Earlier in this course, we talked about owning your map, and you learned a bit about common map design do's and don'ts. Simple design errors can confuse the audience. Our college credit courses at UWF cover map design in great detail. Those with a creative eye and interest in graphic design find this particular component of GIS very interesting. In fact, it's one of the things that I enjoy the most. In the next few slides, I'll share some example GIS outputs created by UWFGIS students. Weather data is something we are familiar with looking at through various news sources. We are used to seeing things like chance of rain or precipitation values in both tables or graphs, like the Google weather update shown here, and on maps used to show weather forecasts. In fact, weather data is geospatial data, and there are several applications involving the use of this. For local weather and data results, a table and graph make sense. This particular map example shows average annual precipitation in Washington state from 1981 to 2010. For this map, you'll have to pay attention to the purpose and results being shown, which is the greatest to least amount of rainfall which has occurred in Washington. If you're like me, you are trained to view water as blue, and you may first interpret the greatest amounts of rain to be taking place in those areas indicated by blue. However, just like the meteorologists do, the significant areas are actually highlighted or symbolized using warm colors like red, orange, and yellow. Why not report average annual precipitation for Washington through a table or graph? Many rain gauges are involved to derive this continuous surface of precipitation. Each rain gauge would have a row on the table, and most audiences aren't used to viewing precipitation data this way. This example comes from a remote sensing and photo interpretation course. Students were provided imagery for a section of UWF campus in Pensacola, Florida, and they were asked to analyze the image using an unsupervised classification to determine land cover and surface area. Unsupervised classification simply means that we let the software analyze the image to tell us where specified land cover types exist. From the table on the map, you can see the different land cover classes identified. Buildings and paved surfaces account for 157.2 acres, while trees and grass represent just over 200 acres collectively. Could we have accomplished the goal presenting these results in tabular form alone? Depending on the audience, yes. Someone less interested in how the results were concluded would only be interested in the resulting values. It's for this reason that the student cartographer makes the table and final results prominent on her map. This last student example is from an advanced GIS course where students are asked to conduct a line of sight analysis to identify possible locations for surveillance cameras near the finish line of 2013 Boston Marathon. This particular assignment was developed soon after the 2013 bombing and is a real-world approach to teaching line of sight analysis. Describing this analysis without the visual aid of a map would be very difficult. There is a lot going on the map, but the main analysis results are shown in the biggest image at the top, depicting the finish line as a yellow triangle. Potential camera locations and the height of the camera as black dots with a number inside and a clean line of sight depicted by green lines. These results are derived from 3D extrusion of the data, which is shown on the bottom left-hand black and white image. It is also clear that this map is not self-explanatory for non-GIS users or those familiar with line-of-sight analysis. A written or verbal explanation in the form of a presentation or short write-up is needed. The need for a description or presentation of visual results like this is true for many geospatial projects. As a cartographer and a GI scientist, it's important to know the data, the methods used, and how to explain the results to both peers and those unfamiliar with the project. UWF students gain experience presenting their GIS projects in formats most utilized in the industry for various audiences. For more student examples, be sure to check out our program blog at uwf-gis.blogspot.com. As a world and nation, we are becoming increasingly used to having access to data and other digital things quickly through our smartphones, tablets, or otherwise through the web. Being able to view, update, and use geospatial data through the web is something that we've seen an increase in as well. This is true for both private and public sectors. For instance, government offices and agencies are required to keep up-to-date data and make those available to the public. The quickest and most user-friendly way to do so is through GIS web applications. The County Property Appraiser's Office is most likely to implement GIS web maps since they deal with property ownership, which changes daily, and receive many requests for geographic information. Business operations like FedEx use web mapping applications to keep track of goods from the time it is collected to the time it's delivered. Drivers have the ability to update delivery status in the field. The web GIS applications I've just described are typically developed by a programmer who knows a bit about GIS. There are several open source options available for those who know programming in GIS. However, Esri has developed a non-programmer friendly platform for users to develop quick web applications called ArcGIS Online. Access is free when you create an online account, and you can access data others have shared publicly. And there are a ton of web maps out there you can view and use. As you might have guessed, presenting results on a web map versus a static map is a bit different. You must still consider the audience and what you want to show, but perhaps even more so than with static reports. That's because not only will the end user be viewing the data, they will likely be using the data as well. In the example, the Women in GIS web map through ArcGIS Online allows visitors to edit the map, as Amber has done by adding a point and credentials to the map. In short, building a web map takes considerably more thought and time to develop and present effectively. Throughout this series, we've considered a healthcare facility example. These types of questions are those that a business, county, or city manager, a decision maker, would ask. So we can assume the audience is for a high-level decision maker who will use the information we provide to determine where new facilities will best serve the population as they perceive it and petition the need for construction of new healthcare facilities. Our recommendations will need to be made clear visually and describe through written or verbal communication. A scenario and project like this tends to lead to several maps in order to fully and properly describe the recommendations. A web map like the one shown here might be nice for the ability to turn on and off certain layers of interest. For instance, population density and a cost distance layer are important aspects of the analysis, but would crowd the map shown together all at once. Not only would a web map allow the decision makers to access from anywhere with an internet connection, but it would also allow them to view specific data that we provide and to easily share it with others. I hope this gives you a clear picture of the typical GIS process and how to use GIS outside of this class.